Another Leetcode problem. 1032 stream of characters. So we are giving a class. So this class is the stream checker. So for the stream checker, we have initialization. So this init is just an array of words. So for example, we have let's just use this example. We have an array of words with CD, F, and KL. And we are also having a method query, and this query is to check the suffix. So for example, for each of the query, we'll get a character. So for the first example, we're gonna get a character A, because there's no string which is add with A, so we're gonna return a false. And now we're gonna add a B. So currently, our string, let me make it right. So our string currently becomes AB. So we're gonna check, is there any words add with AB? No, there's no word, so we're gonna return a false. Now we're gonna add a C to the string. Is there any words add with C or BC or ABC? There's no, we're gonna return false. Now we're gonna add a character D. So we're gonna check, so this CD is add with D, so we're gonna return a true. Now we're going to continue with E, and no words add with E, so we're going to return a false. Now we're going to have F, and there's a word F, which is also adds with F, and we're going to return true. Now we're going to put G, and we're going to return false, H false, I, and J also false, and K also false, because there's no words add with K. There is a K for KL, but it is not at the end. We just needed to check if there's any string which is a suffix of the word. We cannot find, so we're going to return a false. And then we're going to have L. If we have L, so this KL, this L is a suffix string of the KL, so we're going to return a true. So we're going to continue to check like that. As we know, for solving the suffix, it is difficult. I mean, for solving a suffix tree. But if we are solving a prefix tree, it's going to be much easier. Let's just use this x, y, and z. Let's just use this example, x, y, and z. So we have A, B, C, and x, y, z. And we want to check if there's any character or any string which is adds with which is the suffix of the word. So for example, we may have z first, so this is going to be return true. If this is our current character, we put it inside the string, we're going to have a character z, it's going to be true, because x, y, z, it is adds with z, it is okay. Now what happens is that if we put a y to our string, it is add with z and y. So is there any suffix of z and y for the word? There's no, y and z. So let's try to use this example. Maybe first time we're gonna prepare a y, we're gonna return a false, and then we're gonna have a word z, and we're gonna return a true. But what about we just reverse the string? So for example, ABC. If we have ABC, so we're going to prepare a prefix tree. It's going to be CBA. CBA. And similarly here, we're going to have Z, Y, and this is Y, and this is X. Now, how can we check that? So we're going to check this Z, Y, and Z. So for the first one, we're going to check Y. Definitely we're going to return false, because currently we are solving the prefix tree. So for the prefix tree, there's no word starts with Y, because we've already reversed the each of the word inside the words array. We've already reversed. So now we are going to check the prefix. If we have if our first character is Y, we're going to check the prefix, so we're going to return a false. Now we're going to have a Z. But what we're going to do, we're going to reverse this string. Currently we have Y and Z, our string. we're gonna reverse it and turn it to Z and Y. So we are going to check this is Z and Y. This is Z and this is Y. So we're gonna return a true. Yeah. So this is why if we find a problem, if it is difficult to solve by using suffix tree, so definitely we're gonna solve it by using prefix tree. Yeah. So the idea is we're gonna reverse all the word inside the words array, and we also gonna reverse our stream if we have a stream for its. Yeah. So for the next time, if this is Z and Y, for the next time we add an X, and now we're gonna reverse it, let it become X, Y, and Z. So for X and Y, Z, we're gonna continue to check if there is any word start with X. Yeah, if it is X and Y and Z, so we're gonna reverse it to Z, Y, and X. Yeah, if we reverse it to Z, Y, and X, we're gonna continue to check. So we're gonna return a true. Yeah. Now let's try to solve it. And this is a prefix tree. Let me just copy some of the code from the prefix tree, because definitely we're gonna use a template to solve it. So for saving the time. Yeah. So for this prefix tree, basically we have a trie node, and it has a children of dictionary and it has add of word. So the children means there are 26 lowercase English letters normally. So for our letters, it is a lowercase English letters, it is okay. Even it is the uppercase, it is still okay. So we're gonna have another Boolean value, add of a word, it's gonna be true or false, just to check if the word adds with a letter or not. Yeah. Now we are going to prepare a trie class. We're gonna define a trie node, and we prepare some method insert and search. So for this question, I'm gonna use insert and search. Yeah. Now we are going to prepare the trie. First of all, we're gonna define a self.words, so it's gonna be words. But as the words, it may have many characters. Let's just check that. So the word's length is 2000, but it may have duplicate. So the word's I.length is 200, and this is very important. Yeah, because basically, we are going to check a stream of characters, but this stream can be 10 to the power of 4 because it will have 4 times 10 to the power of 4 cows. Yeah, but while we are checking the word, if it is a suffix or if it is a prefix, we don't need to check so long. We just need to check 200. Just in these areas, it is okay because the longest length of the word is just 200. So the time complexity would become 2000 times 200. It is okay. I even tried 2000 times 200 times 200. It can still pass because it is like 10 to the power of 7, but currently we're gonna reduce it to 10 to the power of 5. Yeah, it can also pass for 10 to the power of 7, but it's gonna be very slow. Yeah, now let's also try to check how to solve that. We're gonna prepare a set of words first of all, and we're gonna prepare a string, because for each of the time my string gonna become longer and longer. So from the beginning it's gonna be an empty string. Now I can prepare the trie. So I'm gonna prepare a self.t. It's gonna be the trie. It's gonna be the trie class. Yeah. Now I'm going to do the query part. First of all, a self.s should plus equal to a letter. Yeah. Now I'm going to check the trie, but before that, I'm going to insert all the word inside of the words array. Yeah, I'm going to insert it into the trie. So self.t.insert. Yeah, but for the insert, we're going to reverse the word as I explained earlier. Basically, we need to reverse it, and then, because we are checking the suffix, if we are checking the suffix, normally we're going to reverse each word inside the words array. And while we are querying, we also need to reverse our query of the string. Yeah. So now we reverse the word and put it inside the trie. So we've already built the trie. Now we're gonna use it for the query part. So self.s should plus equal to each of the characters. Yeah. Now we're gonna prepare a reverse string variable. Yeah. It's gonna be empty. So I'm gonna check the length of the self.s. So if length of self.s, if it is less than or equal to 200, so the reverse string, because this kind of a string, it can be more than 200 or it can be less than 200. Yeah. So if it is less than 200, so it is okay. I just need to reverse self.s. Yeah. So I'm gonna reverse it directly. Yeah. But what if it is more than 200? So if the length is more than 200, so for example, the string gonna be like this. But what I need is this part. I just need to reverse this part. Yeah. So how can I reverse this part? So first of all, I'm gonna take out this part from the string s, and then I'm gonna reverse it, right? Yeah. So it's gonna be self.s with minus 200. I just take out the last 200 characters, and then I'm gonna reverse it. So this is gonna be my reverse string. Yeah. Now I get a reverse string. Actually, this is my current word. I need to query with this word. Yeah. So I just need to check. Yeah. So I can return with the self.t and .query. And query, I'm gonna use a search method. Yeah. So inside of the query, I'm gonna search. So I'm gonna search this reverse string. Yeah. Now I need to check the search method. Basically, here is not okay. So this is my previous search. It defined to search a word, but currently, for our string, we have, for example, we have this kind of string, reversed string. We have this kind of string, but we're gonna check all cases. It's not about one case. So for example, this is the trie. Yeah, we're gonna check all the word. If we find a word, we're gonna return a true. If we didn't find, we're gonna return false. So for example, if this is a B, if this B is the end of the word, if we find it, we're gonna return a true immediately. Otherwise, so for example, we're gonna find a B, maybe C here, but our word, maybe if our search word is AB, we're gonna return a true. If it is ABD, we didn't find it, so we're gonna return a false, because this is a C, maybe this is a E. We didn't find it, so we're gonna return a false. Yeah. So we're gonna change the search function a little bit. So here, if this character inside it's not inside current.children, I'm gonna return a false. Otherwise, I'm gonna shift to the next character. But from here, I can check if if current dot, if for the current node, if it is the end of a word, definitely I'm gonna return a true. This means I've already found it, so I can return a true earlier. I don't need to check the word one by one. Otherwise, I'm gonna return a false. Yeah, so this means if I find it directly, I'm gonna return a true. If I didn't find it while I'm trying all the characters inside my string, I'm gonna return a false. Yeah. Now let me just have a check. It seems everything is okay. So here I don't need this one, because for the if else, definitely I gonna have a reverse string. If it is less than equal to 200, definitely. So yeah, I will get my string directly. I gonna reverse it directly. Otherwise, I gonna take the last 200 and reverse it. And then I'm gonna use the search method from the self.trie. Yeah. Now let me run it to check. Yeah, it seems it works, as you can see that. Now let me submit it. Yeah, as you can see, it's pretty fast. Because the time complexity is just 2000 times 200. As you can see, there's no for loop. Here is just a method. And for this method, there are 4 times 10 to the power of 4 queries. And for each of the query, and the longest length of the word is 200. So the time complexity is gonna be 10 to the power of 6. Yeah. If you check my previous submission, I also tried some others. Maybe, let me check another one. It takes even more time. Yeah. So another way is, this is just a method for search a word. This is a normal method for search a word if this word is inside a trie. If we didn't write to return the true directly, and then we have to check the word one by one. So for example, if we have a search word after reverse, it's gonna be ABC. So we have to check A, AB, and ABC. So this definitely takes the time because it's gonna be 10 to the power of 8. Yeah. Let me just try to use this example maybe to have a try. Yeah, let me just use this example. Definitely it also works, but the time complexity gonna be 10 to the power of 8. So 10 to the power of 4 times 200 times 200. But it can still pass. Normally this cannot pass, but it can still pass. As you can see, here is a for loop, and here is another for loop. Yeah, that is why it takes the time. Yeah, so definitely we're gonna optimize these areas. So by optimize the search function. Yeah, so for the search function for a string of word, definitely we're gonna use one search function. It should work. Yeah, this time it didn't work. Yeah, I think it depends. I think previously it works. Let me try to find another one. I think previously it works, but currently it didn't work. Let me try again. Yeah, so this is why it is so slow. We have to optimize. Then let me try this one. Let me try to submit it. Yeah, so even we use trie, we have to be careful to use our method to optimize the code to make it work. Yeah, as you can see, it takes too much time. It passed 18 testing cases, but it's not the best. Yeah, so the best would be here, this one. Definitely, we're gonna optimize the search method. So from the search method, we can check it directly. Even it is a string of word, if the length is just 200. So for example, A, B, C, D. We're gonna check it just using one pass. We don't need to check like A, B. Yeah, because that is repeatedly checked. We just need to check it for one time. If we find it, we're gonna return true directly. Otherwise, we're gonna return false. Thank you for watching. See you next time.